Today we're going to cover section 9. We are going to explore similar solids. Okay, so when we're talking about similar solids, we're talking about two similar cylinders, two similar cubes. We saw this with similar triangles. So here for our similar solids, they're going to be solids of the same type, and like I just said, two cylinders, two cubes, two prisms, something with equal ratios of corresponding linear measures. And these linear measures could be heights, they could be radii, it could be the perimeter. No squared, no cubed, so no area or no volume. So solids with the same equal ratios of corresponding linear measures. A common ratio is called the scale factor of one solid to the other solid. So when we did it with the triangles, the sides were proportional, and when they all simplified to the same ratio, that was our scale factor. So for example, if I draw two cylinders in here, and let's say I draw one cylinder that has a radius of 2.
Pardon the interruption. Olivia Duff, please report to student services. Olivia Duff, please report to student services. Thank you.
And the other radii is 3. I would say that these are two similar cylinders, and their scale factor, when I compare the two radii, is 2 to 3. Know that any two cubes are always similar because all sides are the same in a cube. So all sides would simplify to the same ratio. And any two spheres are similar. They only have one linear measurement, and in the sphere it's the radius. So all spheres are similar and all cubes are similar. So any two that you would choose, they would be similar. Pretty good?
What do you mean by equal ratio?
So, like for example, when we did the triangles, so, for example, if I had a small triangle here and a larger one here, and let's say the smaller one had sides 3, 4, 5, and then the larger one 6, 8, 10, know when you match the sides, 3 and the 6, it'll simplify to a half. So when all the sides match up, all the corresponding linear measures in these solids match up and they all simplify to the same ratio, that is our scale factor. So this one would have a scale factor of 1 to 2. So that's what I mean by the corresponding ratio or the common ratio. I'm sorry? Then they're similar. Now, when you're doing the homework tonight, that's what you're going to be doing. You're going to match up the sides and you're going to make sure that they all simplify to the same ratio. If they don't, then you're going to say that the solids are not similar. Okay, so again, remember any two cubes are similar and any two spheres are similar. Let's go to the next slide. So here is our similar solids theorem. And this states that if two similar solids have a scale factor of A to B, then their corresponding areas have a ratio of A squared to B squared, and their corresponding volumes have a ratio of A cubed to B cubed. So once we know the scale factor, we could figure out a missing area without having to do the whole formula by setting up a proportion. And we're going to see how this works in a minute. Everybody good on this one? This is the theorem that we're going to be using in the homework. So let's go ahead and do some examples. So the first question says, are all spheres similar? We just saw it on the other slide. And yes, they are, because they have only one linear measurement, which is the radius. So you would set up only one scale factor or one ratio, and that would be your scale factor. So this answer is yes. Okay, let me jump to part C, or example C. Are all cubes similar? Yes. Okay, because all sides are the same. So it wouldn't matter if I had a small cube here and a larger one, they're all going to simplify to the same thing. So if this is like 3 and a 3 and a 3, and say this is a 6, and a 6, it didn't matter. Every time you match the sides, they're all going to simplify to 1 to 2. Now, for the right cylinders, are all right cylinders similar?
No.
No. Sometimes they are, but not always. And I'm going to give you an example of each. Okay, the first one I'm going to set up, because the radii would be similar, however, the height's not necessarily. So I could have a shorter cylinder, and let's say it has a radius of 3 and a height of 4. And then I have another taller one, and let's say its radius is 6 and its height is 8. Now, when I go to check these ratios, I can either decide to simplify it like 3 to 4. I could take the radius over height and then the radius over height, and notice they both simplify to 3 to 4. Or I could take radii to radii and height to height. Now, if it were asking for the scale factor, that would be the ratio I would need. So I would have to include in my fraction something from the small one, something from the large one. So if I were doing radius to radius, it would go 1 to 2, and then height to height would also be 1 to 2. Okay, what we're looking for in the homework is to find the scale factor and to say if they're similar. So the scale factor would be 1 to 2. You couldn't use the same measurements from the same solid in the fraction to get a scale factor. Now I'm going to show you an example where the two right cylinders are not similar. So let's say I change one of these heights, and let me go ahead and shrink this over, and I'm going to draw 2 more cylinders. I'm going to keep the first one the same. I'm going to keep it with a radius of 3 and a height of 4. But my second cylinder that I'm going to compare it with, I'm going to keep the radius 6, but I'm going to change the height to this thing and make it 5. So now when I go to compare my ratios, 3 to 4 for radius to height, and then 6 to 5, we can see that they're not the same. Okay, so this is an example of a right cylinder that would not be similar. The radiuses, you would match them, or you could even do 3 to 6 and do radii to radii, and then 4 to 5. Either way, you're seeing that the ratios are not matching, so these would not be similar figures. Next slide. 2 cones. I'm going to go ahead and give you guys a visual. I'll draw you a picture. I'm going to draw my cones upside down. So I have a cone here, and let me do it with a pen. So here's my cone. This is the first one. Now, notice it says that 2 cones have a base radii of 8 centimeters and 12, and height 16 and 24 respectively. So this word respectively is telling me that the 8 and the 16 match, and the 12 and the 24 match. So this one has a radius of 8, and then it's got a height of 16. Now, if you wanted to draw your cone this way, you could draw it, up and down this way. It doesn't really matter. So then here I've got my other cone, and it's got a radius of 12, and this height is 24. And again, they're not drawn to scale. So now I need to check to see if they're similar. So I need to match, and I can either set it up as the information from the smaller cone together, 8 over 16, simplifies 1 to 2, and then the larger cone, 12 to 24, simplifies 1 to 2. However, if I needed a scale factor, I would have to match radii with radii and height with height. And then I could simplify. So I could divide the top 8 over 12, divide them both by 4, and get 2 to 3. And then here I could divide them both by 8 and also get 2 to 3. These are similar cones, and my scale factor would be 2 to 3. Make sense? Now, back on that theorem that we learned about, remember it told you that if you knew the scale factor, it was A to B. The area scale factor would be A squared to B squared, and then the volume would be A cubed to B cubed. So let's say I wanted to find the ratio for the area. I would take my scale factor 2 to 3, square it, and that would give me my scale factor for my areas. If I wanted to find it for the volumes, I would cube these numbers. 2 to the third power is 8. 3 to the third power is 27. This is what we're going to be doing in the homework. Okay, we have one more example. And here's how we're going to apply the similar theorem. So here it says 2 similar square pyramids have base areas of 4 meters squared and 36 meters squared. Find the ratio of the heights of the pyramids. So if I know my A squared to B squared is already 4 over 36, all I need to do is to turn this into an A to B, I'm going to square root them. So my scale factor, my ratio, is going to be 2 over 6, which will simplify to 1/3. So that would be my ratio of the heights, 1 to 3. And again, you can write a ratio 3 ways, with a colon, as a fraction. These are the most 2 common ways that we would write it. Or you could write it with the word TO. Okay, to find the height, and this is what you're going to do in the homework, they're giving us the height of the larger pyramid. So we're going to set up a proportion. And we are going to do 1 over 3 is equal to x over 27. Because this is the scale factor for the linear measurements, the A to B. And then I would do x over 27. If they told me that was the area, then I would have used the other scale factor, the 4 over 36. So I'm going to cross multiply here. 3 times x, 1 times 27, divide by 3. And I find that the height of the smaller pyramid is 9 meters tall. So we will use these ratios and the similarity theorem to find missing areas or volumes given a scale factor. And that is your lesson on similar figures. Your homework tonight is practice B. Tomorrow we will cover surface area for the prisms and the cylinders. And then the next day, the pyramids and the cones. Then on Friday, we will begin reviewing for the test, which is a week from tomorrow. Due to all the AP exams, we're actually spending 3 days on reviewing. We will review on Friday, Monday, and Tuesday. I know many of you are going to be out on Tuesday taking your mock exam. So Tuesday would be just reserved for any last minute questions that you may have. Those of you who will miss my class, you can always come see me before or after school if you have any last minute questions. But I will give you the review on Friday because I know there's a few sophomores that may miss on Monday. Okay, so you can go ahead and start on your homework. And if you have any questions, let me know. That's it.